Mu3, graphing trig functions, builds on the previous section in that it adds vertical displacement. Vertical displacement is just a fancy term for translating the graph up or down. That happens when you're adding or subtracting a number on the outside of the function, like you see here, it says plus h. Example number 1 is a perfect example. We have sine of the angle x plus 45 degrees plus 1. 1 is the vertical displacement. You're supposed to graph the function and its parent. So like we did in the previous notes, take the angle you're given, x plus 45, put it in the middle of a compound inequality, where the left and the right is one complete period of the parent graph. Then you get x by itself, or whatever variable is there. To do that, you would subtract 45 degrees from the left, the middle, and the right. That would give you the phase shift of negative 45 degrees. The new period would be 315 degrees minus 45 degrees, minus a negative 45 degrees, which would be 360 degrees. So once again, that gives us a phase shift of negative 45 degrees, a new period of 315 degrees minus a negative 45 degrees, which is 360 degrees. Vertical displacement here is 1, and A is also 1. That's the information we need to get this new graph. As we continue, we want to first graph the parent graph of sine. So we make a table of values. Typically, we'll mark our x values with quadrantal angles going from 0 to 360. And we put the corresponding y value. Sine of 0 degrees is 0, sine of 90 is 1, sine of 180 is 0, sine of 270 is negative 1, sine of 360 degrees is 0. Then, to find the points for our new graph, you take the new period, which is 360 degrees, divided by the parent's period, which is also 360. 360 divided by 360 is 1. Multiply that by x. Add in your phase shift, it's negative 45. So each of these x values here, we're going to be subtracting 45 degrees from. 0 minus 45, 90 minus 45, 180 minus 45, 270 minus 45, and 360 minus 45. To find our new y values, we're going to take a times y plus the vertical displacement. A is 1, 1 times y is y, adding your vertical displacement. That means each of these y values are going to all increase by 1. 0 plus 1, 1 plus 1, 0 plus 1, negative 1 plus 1, 0 plus 1. And that gives us our graph. If you look at the blue here, that's the parent graph, we had a point at 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. I chose to count every two spaces as 1 here, and you can do this in lots of different ways. You could have made every one space 1 when you mark your graph. This is what I chose. Then for our y values, or the x and y values for our other graph, the red one, negative 45 degrees is 1, so I put a dot there. 45 degrees is 2. Then we have 135 is 1. Then we have 225 is 0. And then finally we have 315 is 1. What you might want to do when you're doing these graphs, and actually I'm going to tell you to do this, before you graph this new graph, transfer the midline. For example, on the parent graph here, the midline that's halfway through this graph is the x-axis. Well, this vertical displacement is 1. So that midline is translated up 1 unit. So it would be here. That midline, and I spelled midline like I was in kindergarten. That's the line y equals 1 in this case, because it translated up 1. If you draw that midline first, it's going to be easier to put this graph on. So we can see the parent graph and the graph of sine of y equals sine of x plus 45 degrees plus 1. Right, number 2 here, I changed this problem so it says negative cotangent. Please change that in your notes as well. So cotangent, the parent's period is 180 degrees, so it goes from 0 to 180. So you take the angle you're given, 4x minus 90 degrees, put it between the normal beginning and ending of one period of cotangent. Then you try to get x by itself. And add 90 to the left, the middle, and the right, then divide each term by 4. 90 divided by 4 is 22.5. 270 divided by 4 is 67.5. That's going to give us an a of negative 1. Remember I changed the problem so it's a negative times cotangent. Gives me a phase shift of 22.5. That comes from this number right here. Gives me a new period of 45 degrees because I take 67 minus 22.5 degrees, and the vertical displacement is negative 2. That comes from this number here. Now in my table, I am going to find ordered pairs from the parent graph of cotangent. Now if I count by 90s, 0, 90, and 180 degrees, I'm going to have undefined for 0, 0 for 90 degrees, and undefined for 180. Here's what that's going to look like. Have a vertical asymptote on the y-axis. Have a vertical asymptote at 180 degrees. And then I had this point at 0, 90 degrees. Now from memory, I know what this graph looks like. It is curved in this direction, and then when it hits that inflection point, then it's curved in this direction. That's what the parent graph looks like. If you don't remember that's what it looks like, then you may have to do more points in here, like 45 degrees and 135, to figure out what these other numbers are, but I don't think you're going to have to. To graph this graph that we're doing, this red one, negative cotangent of 4x minus 90 degrees minus 2. Take your new period minus your parent's period. So that's going to be 45 divided by 180. That's a fourth. And add in your phase shift of 22.5 degrees. So we're going to take each of the x values and put it into this formula. 1/4 of 0 is 0, plus 22.5 is 22.5. Next, we're going to have a fourth of 90, which is 22.5, plus 22.5 is 45. Finally, we're going to have a fourth of 180, which is 45, plus 22.5, which is 67.5. Here's a pro tip. The starting and ending number that you have here should be the same starting and ending number that you have up here. This is one period. This is also one period. If those numbers aren't the same, you've made a mistake someplace. To find the new y values, you take a times y, a is negative 1 in this case, and add or subtract your vertical displacement. In this case, the vertical displacement is negative 2. If you take an undefined and you multiply it by negative 1 and subtract 2, it doesn't change it. It's still undefined. 0, a negative 0 minus 2 is a negative 2, and then we have undefined once again. Before we graph this function, you want to put your midline in. Assuming that I'm counting by ones here, like so. Our vertical displacement is negative 2, so the midline is going to be here at negative 2. I want you to put that in every time it's not the same as the parent. Now my points that I have 22.5 undefined. That's halfway between 0 and 45 degrees. I have an undefined at 67.5. That's halfway between 45 and 90. And I have a point at 0, negative 2. That's right here on the midline. Now the parent's graph is shaped like this. So this one should also be shaped like that. But a in this case is a negative number that reflects the graph over the x-axis. which means the shape is not exactly like the parents. It is reflected so that this part is here and that this part is here. That's why I changed this problem so you could see what happens. Now notice that would not show up in my table, but you have to remember that when you have a negative coefficient, it reflects it over the x-axis. So that's why it's shaped that way. Number 3, we are supposed to graph the parent and the graph of y equals negative 3 times cosine of 2x minus 180 degrees plus 3. Take the angle you're given, put it in the center of a compound inequality, where the left side of the compound inequality is the beginning of one period of the parent and the right side is the end. So cosine, its period is 360 degrees. So I'm going from 0 to 360. My angle, 2x minus 180, goes in between. Then I get x by itself. Add 180 to the left, the middle, and the right. Then I divide each term by 2. So now my graph, instead of starting at 0 and ending at 360, it's going to start at 90 degrees and it's going to end at 270. That's one complete period. It's not the entire graph, but it's one period. So A is negative 3. That comes from this coefficient. Phase shift is 90 degrees. That comes from here. The period is the end of the period minus the beginning of the period. So its length is 180 degrees. Vertical displacement is 3. That's the number that you're adding or subtracting at the end. So then we fill out our table. We're going to put this first x and y table is for the parent graph. So we're going to do the quadrantal angles from 0 to 360. Cosine of 0 is 1, cosine of 90 is 0, cosine of 180 is negative 1, cosine of 270 is 0, cosine of 360 is 1. That's something that I think you're very fluent in. To find the coefficient of x in our new graph for what x prime is, you take the new period divided by the parent's period. The new period we're saying is 180, the parent's is 360. 180 divided by 360 is 1/2. Add in your phase shift, which we said is 90 degrees. You're going to take then each of these x values and plug them into this. Half of 0 is 0 plus 90 is 90. Half of 90 plus 90 is 45 plus 90, which is 135. Half of 180 plus 90 is 90. 90 and 90 is 180. Half of 270 plus 90 is 135 plus 90, which is 225. Then finally, half of 360 plus 90 is 180 plus 90, which is 270. Once again, going back to the pro tip. This first number, 90 degrees, and this last number, 270 degrees, should be the same numbers that we have up here, the beginning and end of one period. To find the y values, you take a times y and add in your vertical displacement. A is negative 3, vertical displacement is 3. So we take each of these y values, multiply them by negative 3, and then add 3. That's going to give us these y values, 0, 3, 6, 3, and 0. So then we graph. I'm going to first graph the parent graph. I numbered my vertical axis up to 6 because I see that some of these y values get to be as big as 6. So I got 0, 1, so I put a dot there. I got 90, 0, so I put a dot there. I got 180, negative 1, put a dot there, 270, 0, and then 360, 1. The curve is made up of many parts of parabolas. So we got this part here is concave up, this part here is concave down, this part here is concave down. That's y equals cosine of x. Then for the red part here, this other graph, I have a point at 90 degrees 0. Well, let's first put my midline in. I want to always do my midline. Our midline for this has a vertical displacement of 3, so our midline is at y equals 3. Going right through my table. Forgive me, table. All right, so I put these points on. I we got 90, 0. It's right on top of this other point. 135, 3. And then I have 186. And then 225, 3. And then 270, 0. Now, if it looks like these points are upside down compared to the parents, you're correct, because A in this problem was a negative, so it flipped it over. So these points up here is going to be concave down, and then these points at the bottom are the minimums of parabolic shapes that are concave up, like so. So that red part is this graph here. Number 4, we got y equals negative cosine of 1/2 of x minus pi over 2 minus 1. This is in radians, so for some people that makes this harder. 1 period for cosine in radians, it goes from 0 to 2 pi. Put the angle in the middle. I'm going to choose, when I'm doing this problem, since I got these fractions in the middle, they both have the same denominator, I'm going to multiply each term by 2. 0 times 2 is 0, half times 2 is 1, half of pi times 2 is pi, and then 2 times 2 pi is going to be 4 pi. Then I'm going to add pi to the left, the middle, and the right, and get pi is less than or equal to x, which is less than or equal to 5 pi. So my graph is going to start at 0, and it's going to go until it gets to 5 pi. A is negative 1. That's the lead coefficient. Phase shift is pi. That's coming from this. New period is the end of the period minus the beginning. 5 pi minus pi is 4 pi. And then the vertical displacement is negative 1. That comes from this number right here. Filling in my table, these blue numbers you see there for the parent graph, I'm counting by 90 or pi over 2 since I'm in radians. So I get the corresponding y values. To find my new x values, I take the new period, which we said was pi, pardon me, it was 4 pi divided by the parent's period, which is 2 pi. 4 pi divided by 2 pi is 2. Add in your phase shift. There was no phase shift. Yes, there was a phase shift. Phase shift to pi. I just didn't write it down here. So once again, this x prime for this one was 4 pi divided by 2 pi times x plus pi. Pi's cancel. 4 divided by 2 is 2. That's why this is 2x plus pi. Pardon me. Getting my pi's mixed up. So if I take my x values, I'm going to double them and then add pi each time. 2 times 0 plus pi is 0 plus pi, which is pi. 2 times pi over 2 plus pi. 2 times pi over 2 is pi. Let me lose that. 2 times pi over 2 is pi, and then pi plus pi is 2 pi. Then we got 2 times pi plus pi. 2 times pi is 2 pi. 2 pi and a pi is 3 pi. 2 times 3 pi over 2, the 2's cancel, so you get 3 pi plus pi, which is 4 pi. 2 times 2 pi is 4 pi, plus a pi is 5 pi. Got a lot of pi's here. To find the y values, we are going to take a, which is negative 2, multiply it by y, and then subtract 1, our vertical displacement. So we're going to get negative 2 times 1 minus 1, yada, yada, yada. You get these numbers. Now let's graph this sucker. Let me graph the parent first. An ordered pair at 0, 1, and then at pi over 2, 0, then at pi negative 1, 3 pi over 2, 0, and then 2 pi, 1. Knowing what the curve looks like, this is a smooth curve, concave up. This part right here is concave down. This part here is also concave down. To get my new points, let's first graph the midline. Vertical displacement is -1. So I'm going to draw my midline here at y equals -1. Put my points on. I got pi -3 point. 2 pi is -1 point. 3 pi is 1. 4 pi is -1. 5 pi is -3. Whoops, I didn't draw that far enough. That's all the way over here. If I connect those points, then what this curve looks like, it's like this, and like this, and somewhat like that. So there's your graph. Thank you very much.